What's up, Coderbyte? Welcome back to another data structures and algorithms video. I'm Elizabeth, and today we are doing another back to basics problem. I am also currently in Mexico. I'm here until the end of the year, and I'm super excited about that. So if you guys are interested in more of like a vlog type video where it's like a day in the life of a software engineer who's traveling abroad, I'm happy to do that, and I think that would be super fun, something to spice up the channel a little bit. So if you're interested, definitely give this video a like, comment below, tell us what you want. We're here to just make great content for you guys. So we love interacting with you, so please let us know. All right, let's jump into this week's problem. Given a word, write a function that returns the word reversed. Okay, so I think this is a pretty simple problem, right? If you get a word, let's say like hello, we want to return the reverse of that. So that would be OLLEH. Or if we were given a reverse word and we wanted to return the reversed version of the reverse word, we'd get the actual word, right? And I think this is an easy problem if you have access to the data structure stack, right? Because you can just, a stack, if you don't remember, is just a data structure, often as an array, where you push things onto the stack and you pop things off the top. So it's first in, last out, just like a stack of books. If you were to add to the stack of books and then remove things from the stack of books, you would be removing the last book that you put on top of the stack first. But this is going to have a little bit of a twist. Surprise, we only have access to a queue data structure, which follows the first in, first out insertion deletion principle. So we don't have access to a stack. So essentially a queue is similar, right, to when you get online in a store. Whoever gets there first gets served first. And that doesn't help us in reversing anything because whatever we put in it, we're going to get it in the same order that we put it into the queue, right? So that's kind of the twist here. And I guess let's jump right in and I'll show you how we can solve this. Okay, as usual, I'm just in PyCharm right here. This is kind of where I normally run some Python code, and I just have a totally blank file called reverse word. So I think the first thing we want to do is we want some sort of data structure to represent the queue that we have to use, right? Because the interview problem says we only have access to a queue. And I think it's really important to kind of be explicit about the methods of a queue and what we can and can't do here. So I'm going to get started just by making a class of queue. And of course, when you make a class in Python, you start by making an init method with, and it gets that argument self. And I think for this, we're going to want to kind of track this in a list, right? We want to keep all of our elements of our queue in an array or a list. So let's say self.data equals just an empty array. Okay, so this is like the basics of our queue. And then a queue, I think, normally has two methods, enqueue and dequeue. Enqueue meaning, put something on the queue, dequeue meaning take something off of it. So let's, just define those really quick. So let's say def enqueue, enqueue. That's what I have a coworker that always says queue, and I love it. So def enqueue, and that is going to get the self, and then let's say we want to put something in the queue, so that's going to be x, and then to enqueue something, we can just append it to the list, right? It's going to append in the right order. That's just how lists work in Python. So let's say self.data.append x, self.data.append x, and I think maybe we can just return self.data. I'm not sure if we'll need that, but just in case, we can just return the data here. Okay, so that's good for our enqueue method. So let's talk about our dequeue method. So here we have def dequeue, and that also gets self, right? And this is not going to get any other arguments because we're just going to pull the first thing off of the queue. So how are we going to pull the first thing off of the queue? So in Python, you can just call pop and pass in the index, right? So we can pass in the 0th index, and that will always remove the first thing in the queue. So this is going to be self.data.pop, and then we're just going to pass in that 0th index. And then so we're essentially returning the thing that we just dequeued off of our queue. And that's the whole thing. That's the queue class. Again, very straightforward. But the important thing is that we're, actually maintaining that when you dequeue something, it comes off the beginning instead of the end. Okay, so then now we want to kind of talk about our reverse word function, right? So of course, in Python, when we want to run anything, we can just do our if dunder name equals dunder main, right? And then we can call our function. So let's call it reverse word, right? That will work. Reverse word, and then let's pass in hello. That's an easy one. So what we want to do here is we want to somehow reverse this word only really using this queue. So let's define what reverse word is going to look like first. So let's say reverse word, and this is going to take the word, right? And then what we essentially want to do is we want to return the reverse word, right? And let's talk about why a stack would be useful here and what we can do to get around the fact that we're not allowed to use a stack. So a stack would be useful here because if we can just add to a stack every letter in order and then remove from the stack from top to bottom, as you do in a stack, you would automatically get all of the letters reversed because it's first in, last out. That's the definition of reversing something, right? So that's why a stack would be very useful here, and that's why that would not really be a great entropy problem because it's a little too easy. So we only have a queue. So what can we do instead? So I'm just going to put a pass in here because I don't have anything yet for that. But I think what we want to do is we want to somehow implement a stack only using the queue data structure. So how can we do that? How can we use a queue and create a stack from a queue? So this is I love this problem. I think it's super fun because it's very you can think about it very visually, like with stacks and or queues of books or whatever. But I think we might be able to build a stack out of more than one queue. So essentially what I'm thinking is that we are going to add, with each letter, we want to add it to one queue. And then before we add the next letter to that queue, we want to add all of the letters that are already in that first queue to a second queue, add the next letter to the first queue, and then add all of the other letters that we moved to the second queue back to the first queue. And in that way, the last letter is now first in line when we dequeue things from that first queue again. So I hope this will become clearer in code, and it will definitely become clearer when we actually kind of walk through an example and see what's happening. But let's just try and implement a stack with two queues and see where it takes us. Okay, so let's make that stack class. So this is going to be our class stack, and similar to our class of queue, we are going to start with a dunder init method. And I think what we are going to need is for our stack to actually be implemented, we are going to use the queue class, and we are going to use two queue classes. So we're going to use two different queues to kind of, we're going to use those queues in order to construct a stack. So our stack itself is going to need a Q1, right? So this is going to be our first queue, and this is just going to be, an instance of our queue class. And then we're going to need a second one, right? So that's going to be our Q2, and this is also just going to be, instance of our queue class. And so for our stack, I think we're going to want to define two methods. So we're going to want to define a push method, which is going to take something to push onto that stack. And then we're going to want to define eventually a pop, right? So this is going to remove something from the top of the I don't know what I just did. Uh, a pop method, right? And this is just going to remove something from the top of it. So let's just put a pass in there until we get there. So that is going to be pop, and then let's work on our push. Okay, so I'm going to make some comments just to make this super clear what we're doing here. So this is going to be push an item to the top of the stack, right? And this is going to be pop an item off the top of the stack. Okay, so what did I just say, right? We want to somehow, if there's anything in the first queue, we need to move it all when we push a new element onto the stack, because we want the last thing we pushed to be the first thing in the first queue, right? Because that means that's going to be the last thing removed, if that makes sense. So I think what we want to do is, if there's anything already in that first queue, so we can do that by just checking, right? Like while there is length on that first queue, so this is going to be Q1, right? So while the length is not equal to 0, aka there's something there, what do we want to do? We want to take everything from the first queue and we want to put it onto the second queue. So what are our methods in our queue? Let's just look real quick. We have enqueue and dequeue, right? So we want to just enqueue things, and we want to kind of just do it in order of, we want to maintain the order of whatever's in the first queue. So we can just say that we want to put on the second queue, right? So this is going to be self.secondQueue or Q2 dot enqueue. And then we want to just dequeue whatever is on the first queue, right? So that's going to kind of retain that order and just kind of say, like, take things from the beginning of the first one, put it on the beginning of the second one. So this is going to be self.q1.dequeue, right? So this is, again, taking from the beginning of the first queue, and we are just putting it into the beginning of the second queue. And this, we do this for each of the things in the first queue. So, okay, so at this point, we've moved everything from the first queue to the second queue. Now, what do we want to do with X that we got? We want to push it onto that first queue, right? So we can do self.q1.enqueue, and then we can just, give it X, right? So at this stage, we have the thing that we're trying to push onto the stack, and it's in the first queue. And we have everything that was already there in the second queue. So that's good, right? Because we want that first thing, the last thing pushed, which is X, to be the first thing out. So now it will be, because it's in the 0th index of the first queue. So now we want to put everything from the second queue that we moved back onto the first queue on top of the X, right? The thing we just put there. So that is kind of maintaining that ordering that we'd like. So we can do the same thing that we did above. We can do a while loop. So this is going to be while there's any length on that self.secondQueue, right? Or Q2, whatever. So again, this is not actually going to be a thing, right? So .data, that's where we're storing what's in the queue. You can look at the class above if you forgot how we implemented this. And while that's not equal to 0, we want to enqueue, right? So we want to enqueue whatever we're dequeuing off of the second queue. Wow, say queue a million times and you feel crazy. Self.q2.dequeue. So that way we kind of take things from in the same exact order and we just put it back where it was, but now X is the first thing rather than the last thing, which is what would have happened if we just called in Q with X. It would have gotten put to the end of the line, and now it's in the beginning of the line, right? And I think that's it. I think, that will take care of actually pushing something. So next we can deal with, popping something, right? So we want to take something off the top of the stack, which is really now just going to be taking something, dequeuing off the beginning of Q1, right? So I think here we would do just return self.q1.dequeue, because now we've reversed the order, but we're still using the principle of first in, first out. The queue is just in the reversed order like we would want it to be in a stack. Again, I think this is difficult to kind of communicate with words without an example, but once we run this code, we'll step through it, we'll see kind of what's happening. And then the only thing I would say here is, we can first check if there's anything in the queue. So we can say, hey, the queue is empty, there's nothing to dequeue. So we can check here if the length of self.queue, that's not how you do that, that's JavaScript. If the length of self.q1.data is 0, we can just, I don't know, print, and this is a stack, right? So we could say stack is empty. Okay, so I think that's it. That's the successful implementation of a stack using only the queue data structure. So we can kind of see this in action before we now implement reverse word using this stack. So I'm going to comment that out, and here we can just say, like, let's kind of look at what we have here. So test stack equals a stack, and then let's say, right, test stack dot let's say push 1, and then 2, and then 3, and then we want to maybe print test stack dot pop, test stack dot pop, and what we want to see here is that we're pushing 1, 2, 3, and we want to return back, we want to print 3, 2, 1, right? That will indicate that we've actually implemented the stack. So let's run this and see what we get here. Oh, I don't want to run reverse word. I want to run, oh yeah, yes we do, because of the file. Okay, object of type Q has no length. Okay, so where are we checking the length? So, okay, so here, again, right, because that's just the whole entire class. This is the actual data inside. So I'm going to also make this a little higher so, we see a little more. And let's run this again. Okay, awesome. So we pushed 1, 2, 3, and when we pop things off, we do in fact get the reverse, right? 3, 2, 1. So it is actually coming off the top of the stack. All right, so that's pretty cool, right? So how can we actually now use this stack to reverse our word? So let's say, right, what do we want to do? Let's talk through it. So we want to go through each letter of the word, and we want to push it onto our stack, which is implemented using 2 queues. And then we just want to capture, in a new string, what happens as we pop things off of that stack, which will reverse the word, right? So let's just, we know we're going to need an instance of our stack, right? So let's say our reversed stack, I don't know, is that confusing? Let's just say, the stack, I don't know, let's say stack lowercase equals big stack. Okay, so now we have a stack, right? And we're just going to loop through the letters of the word. So let's do, 4 letter in word. And what do we want to do? We just want to push the letters in order onto our stack, right? So stack.push, and then we want to push the letters. And then, okay, so we're just going to pop things off and add it to a new string that we're going to return, right? So let's say our reversed word is an empty string, and then we can loop through the letters again. And I think we can loop through just the letters of the word again, because we know that there are only going to be that many letters in the stack, right? Because we've just pushed all of them onto it. So we can say for letter and word, and then I think we can just say, right, reversed word, so that's our string, is going to be whatever it is, so reversed word, and then just concat, right, the reversed, the stack dot pop. And I think that will be, as we pop things off, we're just adding it in order to our reversed word, and then, we'll return our reversed word. And I think that's it. So let's run this, see if we actually, did what we set out to do here. And let's print this. So we're expecting hello reversed. And we do. We get hola, happy Mexico. And then, I don't know, we can do one more test because it's for funsies. Reverse word, let's actually reverse a word. So let's say I can do my name reversed, so TH. Let's see. Elizabeth, so ELISILE. I think that will spell my name. Yeah, all right. Okay, so let's kind of add some breakpoints and debug, because you guys know I love my debugger, and kind of actually walk through like what's happening in this Q1, Q2 business as we do this. So I'm going to add some breakpoints. We can add some breakpoints, let's say like here and here and here and all over, why not? And yeah, so let's kind of watch what happens as as we call these methods. And yeah, so yeah, because that's going to be our push, and I think our pop will be self-explanatory once we see what's in Q1. Okay, so let's run this with a debugger. Okay, so we're here, we have self, right? And we have a self.q1, right? And let's look at what's in Q1, nothing. And let's look at what's in Q2, nothing. Okay, so let's continue. So with our first call, there's nothing in Q1. So we just put the first thing onto the Q1, right? So X is H in this case, because we're reversing hello, right? So we have X, and then we do our enqueue, right? So that's just gonna append it to the data, right? So this is our Q class, remember? So now in our Q1, we have an H, and our Q2 is still empty, right? So there's nothing in Q2, so this is just gonna be, over. Okay, so here we are in reverse word. We've pushed our letter. So the next letter is going to be E, right? So we push E, so let's hop into our push method again. So now we do actually have something in Q1. So let's look at that here. So we have an H in Q1 and nothing in Q2. So what happens? So the first thing we do is we dequeue from Q1, right? So that's H, we're gonna dequeue it, and we are going to just put it in Q2, right? Because that's the definition of our queue. So we've moved it. Now we are going to enqueue E. So E is going to get put into that Q1. So now we have E in our Q1 and we have H in our Q2. Now we are going to put H back into Q1 after E, right? So now we have EH instead of HE, even though that's the order that we've kind of looped through our letters. so that when we DQ, we actually have, there's the letters are essentially in reversed order. So let's see what happens when there's multiple things in the Q1. Okay, so now we are up to L, right? So we're in our push method. We have EH reversed, and we have our Q2, which is empty. So the first thing we do is we DQ from the first one. So the first in, first out with the Q, right? So we take the E first and we put it into our Q2. And then we're going to do the same thing with H. We're just going to DQ it and we're going to InQ it into Q2, and it's going to go in the same order that we had it in because it's going to go to the end of the line. That's the definition of a Q, right? So there we have it. We have EH now in the same order in Q2. Now we are going to InQ L, right? So L is now in the first queue. And now we're going to put all of these back on the first queue after L, right? So we're going to DQ, we're going to take the first thing first. So that's going to be the E, and we're just going to put it to the end of the line in the first queue. So let's watch that. There it goes. And then we're going to do the same thing with H, right? So we're going to DQ it, and we're going to just InQ it to the end of the line of Q1. And so that is how we're kind of actually implementing our stack here, because even though under the hood we're just InQing and DQing things, we're reversing the ordering of the things so that when we DQ, it's coming from the beginning of the queue, but really it's the last thing we put in the queue. So it's like, it's a stack, but using queues. I think that's the whole point. So, play with this with different examples. You all know that I am a huge fan of debuggers and just stepping through code in general to kind of really understand what's happening. And yeah, that's this week's problem. Thanks for joining me this week for another Back to Basics video. I think I'll do a couple more of these and then maybe go back to more of a long form, with, awesome slides and whatever sort of videos in a few weeks. But for now, I'm going to log off and head to the beach. Keep practicing, keep up the good work, everybody, and see you next time.